Okay, so I'm recording, and what I want to do is take a look at questions number 9 and 11 to start out. And so numbers 9 and 11, okay, these are called systems of equations. All right? And I want you guys to just take a look at those real quick. All right? When you have a systems of equations, what exactly do you have? In a system of equations, what you have is you have 2 equations and 2 unknowns. All right? And we see that in problems 9 and 10. Do we see this anywhere else in any other problems? Where you have 2 equations and 2 variables that you need to solve for. 18? Okay. So I want to talk about these and do a lesson in them. And so what I want you guys to do is turn to the very, very back side page where you have a blank sheet of paper, okay? And I want you guys to write at the top of the page, systems of equations, all right? And this is something that I want you guys to recognize. Oops, sorry. Systems of equations. This will pop up, and if you've been in Algebra 1, you've seen it. It's probably been a long time, okay? So this is something I noticed where it's, as I did this, I'm like, there's quite a few questions where this works, where you see systems of equations, and it's something that I believe that everyone should be able to solve, okay? So what you have is you have 2 equations, and you have 2 variables. Okay, and I'll go through the examples explicitly on how I solved them from the problem, but I do want to just talk about this in general, okay? This is what you have to recognize, okay? You have to recognize that you have 2 equations and 2 variables. Here's an example, okay? An example would be like y equals 3x plus 2 and y equals x minus 1. Okay? How many equations do you see? 2. How many variables do I have? 2. Okay? Now, what I want to do, let me jump into Desmos real quick and graph both of these equations. All right, so change this to negative x minus 2. All right? Okay, so what I've done is I've just graphed both of these, okay? And they have a point of intersection. Does anyone remember what I call this thing, the point of intersection? Anybody? The happy place. Oh. Okay. Well, when I zoom in and draw a smiley face, it will. Okay. So you have this this point of intersection. Okay. And this point of intersection, what you have. So let's write that down. Point of intersection. Are we supposed to draw the graph? Not right now. Point of intersection is the solution. Okay? And that's what we're looking for. Okay? When I have this solution, when I have this point, negative 1 comma negative 1, all right, I have an x value and a y value at that point. Okay? And the reason why this is a solution is that it makes both equations true. Okay? Now, I'll show you a couple different ways to solve this, but that's the idea, all right? If I were to make both equations true, I should plug in -1 for x and -1 for y, and it should give me a true statement. So let's look at the first one, okay? Y equals 3x plus 2. If I plug in -1 for y and -1 for x, all right, if I evaluate this, I get a true statement. -1 is equal to 3 times -1 is -3 plus 2. -1 is equal to -3 plus 2 is -1. Okay, that's a true statement. It works. All right. If I plug it into the bottom equation, -x minus 2, so let me write that equation down. Y equals -x minus 2. If I plug in -1 in for y and -1 in for x, then what we end up getting is -1 is equal to, opposite of a negative is +1, minus 2. So you get -1 is equal to -1, which is true. True, yes. T means true. Good question. Okay? Now, what I've done here, all I've done, I found this graphically. Okay? That's what you're doing. We don't have Desmos on the SAT, so we have to know what a system of equations does and how this works. Okay? One way to solve, and so it's got to work for, that point is going to be true for both equations. Okay? So one of the ways where we solve these, so solving a system, is by using this concept of substitution. Okay? What does the concept of substitution mean? Replace. Perfect. Okay? Now in this case, what I'm doing, and I'm going to write this system down again. Y equals 3x plus 2, y equals -x minus 2. If I were solving this system of equations, all right, what I would do is I see that I have y is equal to 3x plus 2 and y is equal to -x minus 2. Doesn't matter how you do this and how you think about it, but what I'm doing is I'm going to take what y is equal to in one equation and replace it with y in the other equation. And what I end up getting is I get 3x plus 2 is equal to -x minus 2. Okay? And what I can do here is I can now solve this equation for x. So if I were to solve this equation for x, I would add x to both sides. So I get 4x plus 2 is equal to -2. Okay? From here, subtract 2 from both sides, and you get 4x is equal to -4. Divide by 4, divide by 4, and you get that x is equal to -1. Okay? Notice what we got here for our x value. We got -1. Okay? Now what I can then do is I can take this value and I can plug it back into either equation and solve for y. So you got to figure out one of the variables first, plug it back into the originals, and solve and figure out the other variable. So in this case, I'll plug it into the top one, and I get that y equals 3 times -1 plus 2. Y equals 3 times -1 is -3 plus 2, which gives me y equals -1. Now, when I get an x value and a y value, that's a point on the graph. -1, comma, -1. Okay? This is just a generic problem. Okay? It's not one of the ones that we looked at. Okay? Have we seen this stuff before?
Yes.
Is it bringing back memories? Hopefully positive memories of butterflies and happy places. Speaking of happy places,
you're totally right.
Honora, please come to the front desk. Honora,
Okay.
to the front desk.
good, good. And guys, I'm showing you a tactic on how to do this. Substitution in this case is probably going to work the majority of the time.
As long as there's a smiley face somewhere on the paper.
There's another method as well. It depends on how you're given the equations. Okay. All right. So let's look at problem number 9. I'm just going to write it down here. This is from your practice sheet. And you have that equation, 3x plus 4y equals -23. And then you have 2y minus x equals -19. Okay? Now, do you have two equations?
Yes.
Do you have two variables?
Yes.
Therefore, this is a system of equations. And it wants to know what's the solution xy for this system. Now, we have different methods of solving this. What I showed you was the substitution method, okay? Now, and I want you to think about this. I'm going through this problem. Like, you got to be able to do this within 60 seconds to 2 minutes. Okay, this is what I mean by there are certain problems that we should be able to do. Systems of equations should be one of them. Okay. Now, in this problem, what I notice is that this is not in slope-intercept form. It's not y equals mx plus b, right? We have two equations in what we call standard form, meaning that the x and y are on the same side of the equal sign, okay? What I do notice is this number here, and I'm going to show you how I went about solving this. I use substitution to solve this equation, okay? What I did in my first step was I solved for x in the bottom equation. Do you guys remember doing this? Maybe, maybe not. Okay. Here is how I would do this problem, okay? What I would do, I'm going to solve this bottom equation for x. So first thing I would do is I would rewrite it. And I would say, all right, I got 2y minus x equals -19. If I'm solving this equation, I can do this a number of ways. But the way I did it was I added x to both sides. And I got 2y is equal to x minus 19. And then I added 19 to both sides. All I'm doing is just moving stuff around. And I get 2y plus 19 is equal to x. I'm just solving that equation for x. Okay? Then what I'd want to do is I would take this equation, 2y plus 19, that expression, and I would substitute it back into x of my top equation, my other equation. So I'm doing the same thing I just did on the previous one, except for I'm adding in another step. So at that point, I did this. I did 3 times 2y plus 19 plus 4y equals -23. And I can solve this equation for y. Go ahead and solve that equation for y. Try that on your own. Don't use a calculator because you aren't given a calculator on this part. Give it a shot. Yeah, these are those, yeah, I mean, and it's that, this is that mental math or paper math, whatever you want to use, to be able to do this, okay? And so if I distribute my 3, 6y plus 57 plus 4y equals negative 23. Combine your like terms. 6y and 4y gives you 10y plus 57 equals negative 23. Subtract 57 from both sides.
Oh, I thought you added.
No. So 10y then gives you negative 70, right?
And negative 80.
Negative 80. See, happens. I do it too. I do it all the time. Divide by 10, divide by 10, and you should get y equals negative 8. Okay? If you got it, awesome. How did you guys do 3 times 19 in your head?
I wrote it out.
Wrote it out?
What I did was, I did 3 times 20.
Uh-huh.
3.
Right. If you guys think about it like this, one way to do mental math is to use the distributive property. If you've got 3 times 19 and that you're like, huh? What do you mean 3 times 19? Put it into something that you know how to do, okay? Rewrite 19 using easy numbers. And what I mean by that is rewrite it using 20 minus 1 and multiply it by 3. This is where the distributive property comes into play, okay? I can rewrite 19 as something else. 3 times 20, we know that in our head. We know that's 60. 3 times negative 1 is minus 3. Gives us 57. Okay, that way will work. You just did it on paper. You did, 3 times 19, whatever. I think I did it that way. I can't remember. This is hard, okay? This is a tricky question. But it's standard, okay? So now you've got y equals negative 8. Look at your answers real quick. So yeah, when you have multiple choice, I would stop at this point, because guess what? You get negative 8 as y. That's the only option. Remember, each of these points is an xy coordinate. If you solve for x, if you were to solve for x, that would have given you what you needed, okay? Because all the x values are different. So as soon as you find that x value, boom, you don't have to go any further than that. Okay? Now let me ask you this. Did anybody do this on the practice? Well, did you get the answer right? Did you get B on this?
Yeah.
You did? Yeah. Okay. Did you guess? Yeah. You have a 25% chance of getting it right. So you probably got a 25% on the test if you guess on everything.
Wait, which question again?
Number, what is this, number 9? And again, guys, this is one where these are problems that we should, we should get right, okay, in my opinion.
We should be getting right now, or that we should be getting right at the end of SAT?
At the end of SAT prep, okay? The heavy focus will be on just generic, more or less on what you need, but I think that you will, I encountered a system of equations quite a bit. It was what stuck out to me as the problem that was like occurring the most, okay? So let's do this another way. That was substitution. Let's use elimination. Yes!
Elimination.
Okay, so hopefully you got space on your paper. Elimination. So this is, you've got 3 options to solve these types of problems. You've got graphing, which we can't do on this, okay? You've got substitution and elimination. That's it, okay? I'm going to rewrite this problem down. And after looking at it a second time, elimination is probably faster. Okay? A different one?
Yeah.
Let's do it on, let's do it on this. We'll have time to do more practice. What time we got? Okay, and I've got 2y minus x equals negative 19. Okay, so solving this using elimination. First thing I want to do, line up my x's, line up my y's. So I'm going to reorder these two numbers here and flip them. And I'm going to rewrite this 3x plus 4y equals negative 23. And I'm going to write negative x plus 2y equals negative 19. Those of you that are pretty familiar with this, which one do you want to get rid of, x or y? The whole point of elimination is that we eliminate. No, I can't do the whole thing. You want to get rid of y? Okay. So what I would do, what you're looking for when you do elimination is you're looking for opposite coefficients. Coefficients are the numbers in front of your variables. Okay? When I'm looking at this coefficient, I have a 3 and I have a negative 1. Here I've got a 4 and a positive 2. What I'm going to do is this. I'm going to multiply this entire bottom equation by negative 2. I'm creating this. The reason why I do that is so that I can get opposite coefficients in front of my y. So distribute your negative 2 into everything, literally everything. And we get 3x plus 4y equals negative 23. And you get positive 2x minus 4y, that's what we're looking for, equals positive 38. Okay? Now, once you get this, then you can simply add these two equations together. All right? 3x plus 2x gives you 5x. 4y minus 4y, it's 0. It gets eliminated, hence the name elimination. Okay? So here's what I got. 5x is equal then to 38 minus 23 is what, 15? Divide everything by 5, which is 5 in Spanish, and you get x is equal to 3. Okay? Again, I don't have to go any further than this. After this little refresher on systems of equations, do you guys like substitution or do you guys like elimination? Do you really? See, I was always substitution. Always. Because to me it made sense. Sometimes you couldn't do substitution. Sometimes, I mean, you can, but a lot of times you're dealing with a lot of like fractions and stuff.
So it's always going to be that they cancel out.
If they're opposite coefficients, yes. Right. Okay. And that's the whole goal, is you have to turn one equation into the opposite coefficient of the other.
How would you get the negative 8 using elimination?
Good question. So you could eliminate x if you wanted to. What you would have done is, and let's just do it real quick. You guys don't have to write this down. You had negative x plus 2y equals negative 19. I would have simply just multiplied this entire equation by 3 to get that opposite coefficient. And you distribute, yeah, you do the same thing. So you get 3x plus 4y equals negative 23. You get negative 3x plus 6y equals, what is that, negative 57? And then add them together. And that's the same thing you had before. Your x's cancel out. You get 10y is equal to negative 70, 80. Dang it! Divide by 10, and so you get y equals negative 8. Same thing. Doesn't matter what you do. All right? But that's that. Okay. Now, knowing this, what I want you guys to do is try number 11. Now, this one's a little trickier because you have you got 3 variables here. All right, let's talk about this one. Let me put it up on the board and we'll look at it. Hey, Eric Clapton. I'm recording this. You're going to be on YouTube. It's going to be tight. Okay. So here's what you have. The equations above. B and C, and I'm just reading this, okay? B and C represent the price per pound in dollars of beef and chicken, respectively. So B represents the price of beef. C represents the price of chicken. When it says respectively, you have to read through, you know, B comes before C in this problem, therefore beef and comes before chicken. B goes with beef, okay, when it says respectively. X weeks after July 1st during last summer. What was the price per pound of beef when it was equal to the price per pound of chicken? There's this funny little joke I used to have growing up. And it was, I had friends coming over. And they were already over. And I'm like, Mom, can we order pizza tonight? And she's like, no, we're having chicken. And I was like, oh, God, chicken again? Ugh. Okay. So in this problem, read the question, okay? What does the question say? What is the price per pound of beef when it's equal to the price per pound of chicken? So I want to find, X when B equals C, and then plug X into the B equation. Okay, that's what I'm doing. All right. Therefore, what I have here is I have a system of equations. Now, the beautiful thing about this is that find X when B equals C. So what I'm going to do is I'm going to do substitution here. And I'm going to take 2.35 plus 0.25x and plug it into here. And basically just set those two expressions equal to each other. And I'm going to get 2.35 plus 0.25x. Man, I'm going to write it down here. 2.35 plus 0.25x is equal to 1.75 plus 0.40x. And I want to solve that for x. Yes, you have decimals. Yes, you can't use a calculator. I'm sorry. So sorry. Okay, so solve for x. Try it on your own. Okay? These are the things that you've got to be able to do. All right? Especially solve an equation like this. So I'm going to subtract 1.75 minus 1.75. Is it 2.35? Yeah. All right, so doing that part in your head. This one I had to just do like the subtraction. I couldn't do this in my head, so 5 minus 5 was 0. 3 minus 7, carry over from the 2, so 13 minus 7 was 60. And then that became a 1, so 1 minus 1 was 0. So this is 0.6, 0.60, all right, plus 0.25x is equal to 0.40x, okay? And then what I did was I subtracted, it's a combined like term, 0.25x minus 0.25x, and I get 0.6 is equal to 0.15x, okay? At this point, this is where it's hard, because you don't have a calculator. Divide by 0.15, divide by 0.15. Okay, when you have this kind of division problem, what I did was I just did 60 divided by 15, which is 4. Okay, so now 4 is equal to x, and then again, that's not my answer, but I got to answer the question, what is the price per pound of beef when it's equal to the price per pound of chicken? So I had to solve for x. Now I have to plug this back in. Ooh, So b is equal to 2.35 plus 0.25 times 4. So if I have 25 cents, multiply it by 4, that's 1. B is equal to 2.35 plus 1, so B is equal to 3.35. Okay? That's my answer. This is still a system of equations. Okay? It's theoretically no different than what we had, and the answer is D here. But what I had to do was truly just read the problem and think about it. What is it asking me? What am I trying to find? How do I do that? And the other thing I had to look at, it's this. Find x when b is equal to c, plug x into the b equation. That's it. Gathering that from this is hard. Okay? Knowing what you know. Solve this equation. Solve the system. Okay, so solve the system. So the last thing we'll do, try and do it in 5 minutes. Okay? 3x plus y equals 8. And guys, I'm making these numbers up so they might be fractions. Sorry. 2x minus 2y equals 16. Okay? You can use elimination. You can use substitution. Okay? Give it a shot. Okay, I'm doing this problem, but it's unfrozen, so no one can actually see this. But I'm going to go ahead and do it anyway. Hold on. I don't know if that's what you get. Straight up dumping.
Oh, wait, no, because I see.
Watch your signs.
Yeah, so it's not like
Opened up my eyes, I saw the sign. Nothing but we got understanding. I saw the sign. Okay, got it. Anybody else get it? Think they got it?
1 minute warning.
Okay. Let me unfreeze it. Okay. So just that practice of
I got an extra y. Were you supposed to put the
Did you use substitution or elimination? You did substitution. Did you do elimination? I did elimination.
were you supposed to put the bottom into the top? Because I put this.
Well, so if you do substitution, you have to isolate the variable. So if I did substitution, what you'd have to do is you'd have to solve this top equation for y. And you'd have to subtract 3x. So it'd be y equals negative 3x plus 8. Keep them. They're yours.
So I should have put that inside. Well,
Right. Then you plug this into y in the other equation.
well, that's why I did it.
2x minus 2 times, but did you get negative 3x plus 8 equals 16?
No, I end up getting like 6x plus 2y minus 2y equals 6.
Yeah, try it again. Keep the original problem. But listen. Keep the original problem.
Yeah, I did.
But you have to isolate. In order to do substitution, you have to isolate one of the variables.
It's just like a quick way to like substitute it into there though. Like 2 times 3x plus y. I'm still that.
No, because look. I have to solve this equation for y up here.
Yeah.
I get y equals this whole thing. Okay? Then I take this entire thing and plug it into y of the other equation. Y equals this whole thing. So I replace y.
Into itself.
Right.
Well, isn't that?
I'm substituting negative 3x plus 8 into y over here because it's equal to
I thought
y.
you substituted it for x. I think that's why I did.
No. I mean, you could, but like,
Yeah, I think.
I wouldn't, I mean, and you could isolate the x or the y down here, but this one's the easiest.
Yeah.
When you do systems, it's the path of least resistance. It's like, what's going to get me there fastest and easiest
Yeah.
without doing the least amount of work. We call that maximization through minimization, and that, my friend, is a life lesson. The only time when you can cross something out, you have to think about what you're doing. You're doing division, okay? When you can cross something out. Now, yes, you are doing division here, but I'm looking for something up here that I'm multiplying by to get rid of it, okay? In this problem, what you would want to do is you'd want to multiply both sides by 3 to get that out. Now, because I did that, and this is a quantity, I can divide out my 3's. That's the moment when I can start crossing stuff out.
Wait, so why would you, so if those are equal, then you can multiply that by 3 and that by 3?
Because what I'm doing,
Because I remember that from Algebra 1.
right, think about it. What am I doing with this 3 here?
So,
Think about what I'm doing, okay? I have this quantity divided by 3. What's the opposite of dividing by 3?
multiplying.
That's why I multiplied both sides by 3.
Okay.
Anytime you're dividing by a number, anything in the denominator, if you multiply by that denominator, it'll divide out and you can move it to the other side.
Yeah. And then, because you can also look at your options and
You just plug numbers in.
if x equals, like, if you would say, like, if you would just go through your options and say, like, x equals 2, 2 minus 1.
Divide that by 3.
Is
Does it give you
1.
Does it give you 3?
No. And then,
Right.
but 9, if you do x minus, but if you plug it in, it doesn't work.
Answer's not 9 though.
Oh,
Answer's
it would
10.
be, what would x be?
What is the value? Yeah, what is the value of x in this equation? And so what you have to think about is, yes, you should be able to plug this number in and get 3. And that's how I did it. Because I'm like, yeah, I could sit here and solve it, but I could just check my answers. So 10 minus 1 is 9 divided by 3 gives you 3. That's true.
Yeah. So they throw you off by putting the 9 in there. Okay.
Okay?
Okay, so I'm not going to